Hello and welcome to this screencast where we will solve exponential equations using the natural logarithm. In a previous video, we developed a rule for logarithms of exponential functions. We found that for any real number t and positive real numbers a and b, the natural log of the quantity a to the t equals t times the natural log of a. This property enables us to move from having a variable in an exponential expression to the variable being part of a linear expression. As a result, it enables us to solve exponential equations exactly, regardless of the base involved. So let's take a look at how we can use this property to solve exponential equations. Solve 5 minus 2 times 3 raised to the 0.6t equals negative 11 exactly, and then find an estimate that is accurate to 5 decimal places. To solve for t, we will reverse the order of operations. First, we will subtract 5 from both sides to get negative 2 times 3 raised to the 0.6t equals negative 16. Then, we divide both sides by negative 2 to get 3 raised to the 0.6t equals 8. Next, we can reverse the exponential function 3 raised to the 0.6t by using the natural logarithm. That means we will take the natural logarithm of both sides. In doing so, we have the natural log of 3 raised to the 0.6t equals the natural log of 8. And by the rule for logarithms of exponential expressions, we can rewrite the left side as 0.6t times the natural log of 3, and that will equal the natural log of 8. Since multiplication is commutative, that is, the order of multiplication doesn't matter, we can also rewrite the left side as 0.6 times the natural log of 3 times t, which will equal the natural log of 8. So lastly, dividing both sides by the quantity 0.6 times the natural log of 3 results in t equals the natural log of 8 divided by 0.6 times the natural log of 3. And using a computation device such as a calculator or Desmos, you should be able to see that t is approximately 3.15465. Let's try one more example. Actually pause the video, try it on your own, and then come back and check. Okay, so hopefully you tried to solve 23 times 0.53 raised to the 2t plus 19 equals 54 exactly, and then find an estimate that is accurate to 5 decimal places on your own. So first we're going to subtract 19 from both sides, giving us 23 times 0.53 raised to the 2t equals 35. And then we divide both sides by 23 to get 0.53 raised to the 2t equals 35 divided by 23. And next we reverse the exponential function 0.53 raised to the 2t by using the natural logarithm. So we take the natural logarithm of both sides, and we have the natural logarithm of 0.53 raised to the 2t equals the natural logarithm of 35 divided by 23. By the rule for logarithms of exponential expressions, we can rewrite the left side as 2t times the natural log of 0.53, and that will still equal the natural log of 35 over 23. We can rewrite the left side as 2 times the natural log of 0.53 times t, so we just rearranged that multiplication, and that will still equal the natural log of 35 over 23. So lastly, divide both sides by 2 times the natural log of 0.53, and our result is that t equals the natural log of the quantity 35 divided by 23, all divided by the quantity 2 times the natural log of 0.53. Using a computation device such as a calculator or Desmos, you should see that t is approximately negative 0.33066. The approach used in these two examples works in a wide range of settings. We can solve for t by first isolating the exponential expression by reversing the order of operations, and then take the natural logarithm of both sides of the equation. I hope you found this video a useful example to help you solve other exponential equations.